Hey everyone, welcome back to Math with Vanch. I'm Vanch, and I'll be teaching you math, obviously. Today we will be covering how to define continuity over an interval and also how to remove discontinuities. So if you're ready, I am too. Let's get started. Okay, so first let's start with continuity over an interval. So here I have the definition of continuity over an interval. It is f of x is continuous over the open interval a to b. The open interval a to b means that we're not including a and b, it's just all the values between those two values. And so f of x is continuous over that interval if and only if every point within the interval a to b is continuous. So what does that mean? So let's start with, in the last video we did continuity at a point. So let's refresh our memory with that. So basically, if we have a function f of x, well, let's start with a point, right? So if we have like, so f of x is continuous when x equals c. So c is going to be our like make-believe point, right? When x equals c, if and only if the limit as x approaches c of f of x equals f of c. So this basically just means that as you approach that c value, it has to approach the same value that f of c actually is. And if it doesn't, then that means it's not continuous at that point. So what the interval definition is saying is that basically every point within the open interval a to b has to be continuous at that point. So basically every point, when you approach every point, it has to equal its actual value. So here I have a function graphed f of x, and as you can see, it's going from, this is going to be around like -6 up until 7, right? And suppose we wanted to know if the function was continuous. Let's do a few intervals, right? So let's start with -6 to -3. So -6 to -3 is going to be here to right about here. So here we can see that every single point within this interval right here is going to be continuous, because when you're drawing it, you don't have to pick up your marker or pen or whatever you're drawing it with. You don't have to pick it up to go from one point to the other. So you can see that it's continuous at every single point within that interval. So this interval will be continuous. Now let's do another one. Let's say we had -3 to 1. So for this one, we have to go from here and then down here, up right until about there. So here we can see that it's not continuous, and that's because we have a discontinuity right here at -2. So from -3 to 1, we can't go from -3 all the way to here on the graph without picking up our marker. We can't kind of like go like that, you know? So we have to go from here, pick up our marker, and then go down here. So because of that, this interval is not going to be continuous. And let's do one last one. Let's go from the interval 3 to 6. And again, same thing. This is about right here, and 6 is going to be down here. So same thing here, we can see that it won't be continuous because we have an infinite discontinuity right here in the middle at 4. So we go up, and then we can't really go all the way to infinity, you know? So we have to come back down right here and stop at 6. So for this reason, it's not continuous over 3 to 6. So another way to think about it is basically if you have any discontinuities over any of these intervals, then it's not going to be continuous over that interval. So like here we have a discontinuity at -2. So because of that, -2 is in between -3 and 1, so it's not continuous over the interval. Since we don't have any discontinuities between -6 and -3, it's continuous over the interval. And same thing with 3 to 6, we have a discontinuity at 4, and 4 is in between 3 to 6, which is why it is not continuous over that interval. Okay, now let's look at how to remove discontinuities. Now this is very similar to what we did when we were solving for limits algebraically, and it's actually pretty much the same thing. But there's only two main ways to do this. So there's the algebraic method, or not the algebraic method, it's the factoring method. So by factoring and by rationalizing. So let's look at both of these separately. So right here we have the function 6x squared plus 18x plus 12 and all that over x plus 2. So for this function, we can see that when x is negative 2, it will be undefined. So when x equals negative 2, this whole function will be undefined. And that is because you can see that the denominator will be 0 when x equals negative 2. Because if we plug in negative 2 right here and we add 2, we get 0, right, in the denominator. So what if we want to remove that discontinuity? By that, I mean basically like rewrite this function so that it's the same for every other value except it will be continuous at this value. So let's try that. So we can factor the numerator. So f of x equals 6. So we can factor out a 6 first, times x squared plus 3x plus 2, and then all of that over x plus 2. Now we can factor this further. So f of x equals 6 times x plus 2 times x plus 1, and then all of that over x plus 2. Now we can see that this and this cancel out, and there we just remove the discontinuity, right? So now we're left with the simplified function 6 times x plus 1. Now this is literally the same exact function as this, except instead of having a discontinuity at negative 2, this function is continuous for all values because there's no value which will give us a discontinuity. So this is how we remove the discontinuity algebraically or using factoring methods. Now let's look at how to remove it using rationalization. Okay, so here we have the function of x, root x plus 4 minus 3 over x minus 5. And we can see x cannot equal 5, and this is because when x equals 5, the denominator will be 0. So how can we make this function so that we remove that discontinuity and x equals 5? And the function can be continuous when x equals 5. So to do that, we see that there's a square root in the numerator. So start by multiplying the function by the conjugate. So we can start off with root x plus 4 minus 3 over x minus 5. And then we'll multiply this by the conjugate of the numerator. So the conjugate is basically the same exact expression, except the sign is flipped. So this would become root x plus 4 plus 3, and then over root x plus 4 plus 3 again. And we can do this because since we're multiplying both the denominator and the numerator by the same thing, it's basically the same thing as multiplying by 1, because this is just 1, right? Because it's the same thing divided by the same thing. So now we're going to simplify this. So this is in the form a minus b times a plus b. So we know that that equals a squared minus b squared. I can write that over here too. So a minus b times a plus b equals a squared minus b squared. So our a in this situation is root x plus 4. So root x plus 4 is just going to be x plus 4. X plus 4. And then our b in this situation is 3. So that's just going to be the same thing. So then b squared is going to be 9. So we have a squared, which is x plus 4, minus b squared, which is going to be 9. So minus 9. And then here we can just write it as it is. So we can just write it like x minus 5 times the whole quantity x plus 4 plus 3. Okay. Now this equals, I'll try to write it smaller here. So x minus 5, because plus 4 minus 9 is going to be minus 5. And then down here we have x minus 5 times root x plus 4 minus 3. And now we can cancel out this and that because it's the same on the top and bottom. So then we will be left with 1 over root x plus 4 minus 3. And here you can see that this value is actually wait. Oh, this is going to be plus. My bad. Sorry about that. So yeah. Now we can see that this function is actually going to be defined when x equals 5. So we can try plugging it in. So like 1 over root 5 plus 4. So 1 over root 5 plus 4 plus 3. 5 plus 4 is 9. Root 9 is 3. So 1 over 3 plus 3, which is going to be 1 over 6. So here we can see that this function, although it's the same exact function as the top function, all we did is multiply by the conjugate. It's the same exact function, except now it is continuous when x equals 5. And that's how we remove the discontinuity using rationalization. Now that is going to be it for this video. I hope you found the video helpful. And if you have any feedback, please let me know in the comments. Otherwise, I will see you for the next video. Bye-bye.